Okay, so you should have been able to identify the A, the H, the K in the equation, and the idea is to be able to graph functions very quickly without having to plug into a table. So we don't want you guys to lose the idea that you can plug into a table. You can always do that, but you're not always going to really know what a shape looks like by doing that, because if things twist and turn and curve around and that's not the one number you plugged in, then you don't see that twist and turn and curve. So we want you to know every function's shape, and we want you to have the main idea of how to get the aspects of that shape without having to plug in. And then if you ever felt stuck, you could go plug in a couple things to help you along, that kind of idea. Okay, so we know the absolute value shape like a V. Okay, and then our idea is to kind of be able to get that quickly just from the equation. So our A value here is -2/3. Our H should be a +2, and our K should be a +6. Is everybody okay with how I picked out those values? Right, and so H and K were the shifting left and right, which means instead of at 0, 0, we've shifted 2 to the right and 6 up. And so our new vertex should be at 2, 6. So 2, 1, 2, 3, 4, 5, 6. So then you kind of have that vertex point on your graph immediately. And then from there, we know the absolute value looks like a V, and it's made up of these two lines with opposite slopes. Should this V open upward or downward? Downward, because the A value is negative, right? And compared to the parent function, do you expect it to be more narrow, like with steeper lines, or wider? Wider, right? Because our parent function has slopes of 1s for the lines, and this is 2/3, which is a little bit less than 1. So the lines will not be as steep, making the V a little bit wider. So I'm going to go down 2 and over 3. That gives me a point. And if I mirror that on the other side, I have another one of those. If you want more guiding points, you could continue that pattern. And then you should be able to see what your function would look like. Is the graphing portion of this okay with everybody? All right, so those themes that we learned from the investigation make it really simple for us to graph this. We'll never miss the point where it turns around because we know how to put that on there first, and we'll have how wide and how narrow it is by the slope that's controlling it. And so then we want to be able to go through and list all of these aspects. So we've already mentioned vertex, and we said it was at the point 2, 6. I'm going to come back to the X and Y intercepts, but I want to go through the other things because they're simply pulled off from the graph. Sometimes the X and Y intercepts are pulled off from the graph, and sometimes they require a little more work. And I want to make sure you have kind of different approaches to that in case they do require more work. So can somebody give me the domain of the function? Yeah, Beverly. Good. So the domain is all real numbers. Every X value can be plugged in and produces a Y value. Or if you like to write that in interval notation, from -infinity to infinity. Okay. Somebody else, what about the range of our function? Dylan?
Y is less than or equal to 6.
Good. So 6 was that maximum value at our vertex, and the graph only existed below it. So we'd only get Y values that are at or below 6. And in interval notation, that would be from -infinity until 6. And 6 would use that square bracket, indicating that we actually reach 6. Right, increasing interval. Who thinks they can give us the answer to that? Morgan? Okay, so -infinity until what? 6. Okay, so let's take a look and see. So remember how we labeled this yesterday, or not yesterday. In my head, it's yesterday. Oh, so smart. Good fix. Okay. Good. Did you guys hear her correction? So let's check out this one. So you should have been able to understand that this is the increasing part of the graph, right? And this is the decreasing part of the graph. And then remember, we label them not what it's increasing to or what it's decreasing to. Our minimums and maximums in our range tell us that. Instead, we list the X values and we're saying, hey, the graph behaves like an increasing thing on these X values. So do you guys see that fix that she made? That the X value where these change behavior is lined up with 2, and that the increasing is from infinitely small until X reaches 2, and then it's decreasing beyond 2 towards positive numbers. So her increasing interval is -infinity until 2. And you can use a parenthesis or a square bracket there because it's kind of like not defined specifically. And that would make our decreasing interval the other side of our domain, so from 2 to infinity. Any questions on increasing or decreasing interval? Because that's probably a newer thing for you guys, and the notation is not about the numbers we're reaching, and so it's really hard to kind of like wrap our mind around that sometimes. All right, somebody new. Is this graph 1-to-1? Taylor? No. All right, somebody else, rate of change for the graph. Someone that hasn't talked to us yet. Shirley? Good. We have this slope of 2/3, but because the absolute value is really like a piecewise function made up of two lines, we have one with a slope of positive 2/3 and one with a slope of negative 2/3. Axis of symmetry. Somebody that hasn't talked to us yet. Brandon? Good. X equals 2, okay? Minimum value. New people were making it. Emily? None. Good. Okay. And you guys don't need to write negative infinity. It doesn't have a minimum value. Negative infinity is not actually a value. Okay. And then what about our maximum value? Susan? Good. 6. Okay. And then the asymptotes don't apply to this function. This is not a function that has these characteristics. Yes. Sorry. Thanks. Does everybody feel like they have kind of the basic idea of the absolute value function? Right? All right, so we're going to look at a couple of things in your note guide. This becomes part of your notes and is also something we scan into your portfolio, and you'll get kind of a collection of papers that all look like this for every type of graph that we study. Every unit, you're going to be filling out 1 or 2 of these because we keep graphing functions and we try to keep graphing them this way. We try to be able to identify their shape and their key features very quickly so that we're not constantly building tables to try and graph them, okay? It's not a bad idea, it just doesn't always give us the whole picture. So you guys have a note guide or you take notes in your own paper. And the first thing I want you guys to do, so I'm going to stop talking for a minute. I'm sure you'll be grateful for that. The first thing I want you guys to do is review again. I know I'm kind of just like hitting you guys over the head with it, but just take a moment to look. We filled this in yesterday. We went over it twice in the investigation. We went back through and graded it. But maybe quiz each other at your table or make sure everybody has an answer for each of these. Do you know how to determine if the graph will open up or down? How does A affect the graph? How does H affect the graph? How does K affect the graph? And the reason that we're being so specific about this is 2 things, 2 very important things. Number 1, those are exactly the things I had to know to get a quick graph of that function, right? My thought process was H and K make my vertex. A is my slope, but I have to know whether I'm facing the V downward or upward. That's why I want to know what they do for graphing. The second thing is, in addition to those characteristics that we just listed, you are going to start being asked what the transformations are of the graph. Because we want to know all the parent functions, the basic ones, like in our head. And we want to know, like, when you put these numbers, what does that do to the V? Does it make it wider or narrower? Does it shift it to the left or to the right or up or down? So if you understand what each of these things do, you'll be able to answer those questions a lot quicker and graph your function very quickly. Okay, so take a minute at your table, look around other graphs. So I didn't want to move that. I wanted to move you. All right, so right here, there's just some notes. If you get stuck, you can come back and look at that as a way to graph. All right, this first example, we're doing 2 things. We're going to write the equation as an absolute value function and then also as a piecewise function. So when we talk about part A and we're talking about writing it as an absolute value function, we're looking at filling in this information. When we look at part B and it says write it as a piecewise function, if you view an absolute value function as a piecewise, how many different pieces does it have? 2, right? There's 2 pieces. They're both linear. And their slopes are the same, right? Because they climb at the same rate, except for different signs. So same number, different signs. So that's how I'm going to put these together. So when I look at the function, Remember what's important for us to pick out. We want the vertex and we want to be able to clearly see the slope of the function. So my vertex is at this point right here, which is, here's the origin. So that's 2, 1. Okay. So my vertex is at 2, 1. And then my slope goes up 1 over 4. And do I want the a value of this absolute value function to be positive or negative? Positive, right? Because it's opening upward. I'm just going to plug the appropriate values into their appropriate place. My vertex is supposed to represent my h and my k value, and my slope is my a value. So I have a positive 1/4 because it opens up, x minus 2 because 2 is my h value, and plus 1 because 1 is my k value. If I wanted to write the piecewise function version of this, I've kind of set up all my expectations. So I expect 2 pieces. Okay. They switch right here at the vertex, so that's lined up with 2. So I expect 1 equation of a line when x is less than 2 and 1 when it's more than 2, and I'll make sure they overlap and have that equal sign somewhere in there. So this line on this side, okay, its slope is equal to what? We already counted it. It's 1/4. The question is that a positive 1/4 sloping line or a negative 1/4 sloping line? This one on the left side. If you read the graph from left to right, that portion that I've drawn in red, does it have a slope that's going downward or upward from left to right? Downward, right? It's decreasing. That decreasing section is the piece that has the slope that would be negative, okay? So this first piece has a negative 1/4 slope, where the second piece will have a positive 1/4 slope, okay? They will not have the same y-intercept. Are you guys okay with that? You can actually see the piece that I wrote in red where it crosses the y-axis. We might be unsure of the value. We'll figure it out in a minute. And the other one, you cannot see the place that it crosses the y-axis. You'd have to extend the line to see it. If you guys can't easily count the y-intercept off of the graph, our strategy was to pretend like we're writing the equation of a line. So like right now, we have y equals negative 1/4 x, and I'm trying to figure out the y-intercept. And then just pick a point it goes through and plug in and find its y-intercept. So both these lines are supposed to cross through that vertex point, right, which is 2, 1. So I'm going to plug in the point 2, 1. 1 for y when 2 is for x. And then I'm going to finish the arithmetic for this. Okay? And so then I would add 1/2 to each side. So b is going to equal 1 1/2 or 3/2 for that first line. That makes sense. There's my origin. It looks like it's about 1 1/2. So that's the y-intercept for this line, and this was the branch that was happening when x was on the left side of 2. Okay. And now I want to repeat this process for the branch that's on the right side of 2. And again, I don't see its y-intercept. I don't know that it's going to be easy to count, so I'm going to use the same strategy I just did. For this new line, it's also supposed to cross through the point 2, 1, so I'm going to use that to plug in again. And this will help me solve for the y-intercept. Okay. This time I'm subtracting 1/2 to solve for the y-intercept, so I would get that b is equal to 1/2. So that's the b value I'll use, and these are for x's that are greater than, and then one of them has to have the equal to. It wouldn't matter which one. Okay. Any questions on how I got the piecewise part? Because this is a good review from our last section. Mark? So right here at 2 is where it kind of broke it into 2 functions. So on this side would be the x is smaller than 2, so they went with this line. And on this side would be the x is bigger than 2, so they'd go with the other portion. Is that okay? All right, so we're going to do a couple of graphs here. Actually, given time and like intercepts, we're going to go do number 4. Do you see number 4 up there? Okay, it's a little more complicated than things you've done before. And then we're going to go back and make sure you have a way to find intercepts. So we want to graph number 4. So we're concentrating on this one right now. So what is a little bit confusing about the way that this is written?
There's an A value.
Good. Good. There's not an A value, but then like maybe there is. Instead, there's something in front of the X. We're actually going to call that a B value later. Like we're going to give it a different name. But with absolute value, the function works very specifically. So I'm going to do a couple things and make sure you guys understand that it's okay for me to do them. First of all, would you guys agree I could rewrite this where I can kind of separate the -1/4 from the rest of the stuff that's in the absolute value, like undistribute it, factor it out. Okay. And then what would that set of parentheses look like when I factor out the -1/4? The first term would be x, okay, because -1/4 times x would make -1/4 x. What would the second term be? So it was a 1, but now we have factored a -1/4 out of the 1. Good, it would be 4 because 1/4 times 4 makes 1, or 1 divided by 1/4 leaves us with 4. Would it be a -4 or a +4? Negative, okay. It was positive, but that negative times the negative is what would make the positive. Is everybody okay with what I've just written is equivalent to what was there before? I didn't do anything new. I wrote it in a different way, okay? You might not understand why I'd want to do that yet, but we're okay with that. The second thing I want you guys to remember is the properties of absolute value. Are you guys okay that like if I was doing, if I was doing -3 times 2 inside of absolute values, that's equal to -3, absolute value times 2 absolute value? Is that okay with everybody? That because absolute value only changes the sign of the number, and in multiplication, that means it will never change how they multiply each other, right? Okay. It would change how they add each other, right? You can't separate it up with addition because changing something to a positive, then adding it might change it. But in multiplication, it doesn't. So what I'm going to do right here is I'm actually going to separate the two things that are being multiplied. The -1/4 is multiplying the x minus 4. And then the hope is that now you can see why I had a motivation to do this. I am trying to take out the piece I do know so it can act more like that A I'm used to seeing, and I can still have the A and the H and the K set up. See, the thing is, I still don't know the absolute value of x minus 4. It has x in there. I don't know how that's going to work out. I can't do anything with those absolute value signs. However, I do know the absolute value of -1/4. What is the absolute value of -1/4? 1/4. So this is 1/4 times the absolute value of x minus 4 plus 2. So that's how we'll deal with that. If it's not set up the way that we want it to be, we can make it set up the way we want it to be. Okay? And then now we can graph like we did before, over 4 and up 2, and then a slope of 1/4. So up 1 over 4. It's kind of off my graph over here, but you guys get the idea. Something like this if I could draw straight lines, but I can't. Okay? Is this all right with everybody? So I think we're pretty good on the graphing. I just wanted to show you that one because if they don't give you the equation exactly how you want it, I want you to feel confident in your like arithmetic skills to manipulate it to look exactly how you want it to look. Okay? So change it and make it how it is. And then let's go one more time back to your Cartesian catalog and talk about those intercepts that we were talking about before. Because I didn't finish it and I don't want to be a liar. All right, so we talked generally yesterday. If you can see them off the graph, I don't care if you pull them off the graph, but it's not always going to be so nice. So y-intercepts are not that bad because for a y-intercept, you plug in 0 for x. And the way that we write our functions means that when we're plugging in 0 for x, we just have a like order of operations, little arithmetic problem to complete, and we have our y value. So 0 minus 2 is -2. But the absolute value of that is actually +2. Then I multiply it by -2/3. And I add that to 6. Okay? And I would want common denominators to do that. So I would think of 6 as 18 over 3. And I'd get 14 over 3. So my y-intercept It's 14 over 3 or 4 2/3. Okay? And that should make sense with what you have on your graph. The x-intercept is more difficult because you're setting y equal to 0. And so here you have to be real careful. You really need to isolate the absolute value part of the equation. Okay? So you should subtract 6 from both sides. And then we want to cancel out that fraction. So I'm actually going to multiply by its reciprocal so that I have the absolute value alone and set equal to whatever I get over here, which in this case ends up being 9. Here's why you get 2 intercepts. You cannot just make the absolute value bars disappear. Okay? Think about if I wrote this up on the board for you guys. If you came in today and I was like, oh, I'm thinking of a mystery number, okay? And my mystery number is something that you take the absolute value of and you get 9. What's my mystery number? What mystery number can take the absolute value and be 9? -9 or 9. So we actually split this into two ideas. We say we know how the absolute value works. If the answer is turning out to be 9, either the stuff inside the absolute value bars was actually equal to 9, or the stuff inside the absolute value bars was actually equal to -9. This is why there's 2 x-intercepts in this function, right? There's 2 options for what the value could be inside those absolute value bars. And so we get one solution of 11 and one solution of -7, and we have 2 x-intercepts, -7, 0 and 11, 0. And I know that you might have just been able to see those off the graph, and it's totally okay to pull them off the graph, but when it doesn't cross through a really nice point on your graph and you can't see it, this is what you're going to have to be able to do to get the fractional value of where it's actually crossing the x-axis. Okay? Is this okay with everybody? So this part shouldn't really feel different than what you've done before. 2 main ideas here. You can't pretend like the bars aren't there. Okay, so that's the number one error I see people do. They just start distributing and solving for x like the absolute value bars aren't there. They are there and they do mean something, so don't ignore them. Okay, so your first focus needs to be to get that portion alone, and then you need to understand what absolute value means. Okay, if you understand what absolute value does, you can understand why we said that x minus 2 could be equal to +9 or it could be equal to -9, and those are our 2 options. You cannot set that up before the absolute value is alone. Like, you cannot at this point be like, oh, this could equal -6 or this could equal +6. Maybe, but sometimes that won't work for you depending on if there's addition or subtraction in there instead of just multiplication. It gets a little complicated. So if you'd like to follow this process every time, you need to isolate the absolute value first, and then you can analyze it and say, oh, it could be this number or this number, and set up your 2 separate equations without any absolute value bars in order to solve. Okay? Does this make sense with everybody? All right, so your homework tonight is actually 2 skills.